In the last video, we saw the increases in greenhouse gases that are occurring in the last decades. And the question is whether this is really unusual. Is this something that has happened in the past, even tens of thousands of years ago, 100,000 years ago? Or maybe it's something that we don't have to worry about because it happens all the time. So we have to become a little like a detective, a climate detective, to try to study what happened in the past. We don't have data, the actual direct measurements like we showed in the previous lecture, previous video of actual measurements of carbon dioxide and methane. So we have to figure out how we can get this information from long periods, from thousands of years ago. And the main one I want to talk about here is using ice cores. In the next lecture, we'll talk about other methods, but ice cores are one of the key tools we use to study the climate of the past. And we can only get ice cores in places where we have ice, which means that the ice doesn't melt during the summer, that it continues to remain throughout the summer, and then the next winter we may get more ice. And there are really only two places on the planet, Greenland and Antarctica, maybe a few ice sheets in Patagonia, but the two main locations we can use this methodology are in Greenland and Antarctica. And here we can see a scientific base in Antarctica with the scientists here are holding pieces of this ice core. Ice core is basically obtained by drilling down into the ice and taking out these cores of ice and then trying to study them to get information about the past climate. Now, when we open up the ice, and what's special about ice is that when the ice forms, it traps in little bubbles of air. And you can see in this piece of ice here, the little white dots are the actual air bubbles inside the ice. Now, actually, how does ice form? So in Antarctica and Greenland, we have ice which will fall down during the winter months. And when the ice gets to about 150 meters depth, it's heavy enough to compact the snow into ice below it. And so once we have that compaction, the air that is in the snow will be trapped inside the ice and will remain there basically forever until we open up the ice. So if that ice formed 10,000 years ago and we open up those bubbles today, we can measure what was in the atmosphere 10,000 years ago. And the further down we drill into the ice, the further back in time we go. And so the ice sheets are kind of like an archive of the climate. It gives us a lot of information, what happened in hundreds of thousands of years ago, and that gives us a lot of information of what is actually happening on planet Earth. In the previous video, we actually saw this up and down motion of the breathing of the planet. In the background, you can see the vegetation, both on land and in the ocean, which is taking up carbon dioxide due to photosynthesis and then releasing it back into the atmosphere. And we can see the actual month of the year that this is occurring. But this, as I mentioned, goes back only to 1957. If we want to go back further in time, then we have to go to the ice cores. And when we go to the ice cores and we look at what's the concentrations of carbon dioxide in the ice cores, we see that this is truly anomalous. And we can see here on this plot from 1,000 years ago, today we're in the 2000s, so 1,000 years ago, we see the line is more or less straight here, around about 280 of these units, parts per million. So for every million molecules, about 280. And then something happened after the 1800s, 1900s, and it started to go up. And it continues today to go up. Well, we can go back even further. So here we have 2,000 years of data from the ice cores. And here the different plots are not just carbon dioxide. We see carbon dioxide in red. We see the nitrous oxide in black and the methane in blue. The scales are very different, but the point here is that all three of these were more or less stable for 2,000 years. And then at the same time, they all started to rise as though it's a straight line going straight up and continue today. We can go back also with temperature. So the ice sheets and the samples of the ice can tell us something about the greenhouse gases, but we can also use certain methods, chemical methods, to estimate the temperature relative to today in the past. And in addition to the ice cores, we can also use tree rings, we can use pollen, we can use corals, and we'll talk about that again in the next lesson. But we can see here, we can go back 2,000 years. Today we're in the 2000s, and the dark plot at the end here, the last section of this plot, is what we saw in the previous lectures from what we see from the actual instrumental data just for the last 150 years. But the rest of the data is from these proxies, from ice cores, from tree rings, which shows that the temperature in the last 2,000 years was also fairly stable, with fluctuations around plus minus 0.2 degrees. And then again, around about 1850, 1900s, things changed direction and started to go up. And as I mentioned, the IPCC report from 2021 showed that we've warmed up now about 1.1 degree relative to this period in the 1800s and 1900, beginning of the 1900s. And we can also see here the two lines, the thresholds at the top of the Paris Accord, the United Nations conference in Paris in 2015, where they decided that we shouldn't really pass 2 degrees global warming or even 1.5 degrees, which was updated in the Glasgow conference in 2021, and that if we do pass these thresholds, we may have irreversible climate change. We may pass some tipping points that we may have to live with these changes, and also that we may have some dangerous consequences if we pass these thresholds. What exactly that means, dangerous, is difficult to say, but the warmer the planet gets, as we'll see throughout this course, the more difficult it's going to be for all of us to live here. We can go back 10,000 years here in the ice cores and look at the carbon dioxide in the bubbles in the ice. And here too, the different colors are just cores from different locations, and so we can see that they agree fairly well. Carbon dioxide, as I mentioned, has a very long lifetime, so it spreads around the planet, and so it doesn't really matter where we measure it. If we measure it in Tel Aviv, New York, in Greenland, in Antarctica, the concentrations are basically the same. And that we can see by these different colored points here on the plot. But again, the message here is in the last 10,000 years, the carbon dioxide hasn't changed that much in the atmosphere. And then something happened around about 1800s, 1850, and it's shooting up. And now we're reaching 420 ppm. In addition to carbon dioxide, which is again shown on the top plot here, we can also do the same for 10,000 years of methane measurements in the ice, and at the bottom 10,000 years of nitrous oxide. And again, we see that all of these were more or less stable over 10,000 years, and then they just take off and are going way up and not stopping, with carbon dioxide's increased by about 35% since this initial takeoff in about 1850. Methane nearly 200% increase, and nitrous oxide about 25%. If you now ask the skeptics or the deniers of climate change, what happened here? How do we explain such a dramatic shift and a dramatic increase in greenhouse gases when it was more or less stable for 10,000 years? They have no answers. There's no explanation. Nothing natural happened on planet Earth at that time. Nothing with the sun, nothing with the oceans, no volcanoes. The only thing that happened was the Industrial Revolution. Industrial Revolution, we started to burn fossil fuels, build our cities, trains, ships, cars, electricity for our homes, food for the population, vaccines, medicines, people were living long. So there are a lot of good things which came out of the Industrial Revolution, but as with most things, also some bad things. And those bad things are the greenhouse gases, which are continuing to increase in the atmosphere ever since the Industrial Revolution. Let's go back 420,000 years. So here we can see 420,000 years in the ice cores. On the top we see carbon dioxide, in the middle we see methane, and at the bottom we can actually see the temperature, but this is the relative temperature. Again, no one was living there and had thermometers. We use some chemical methodology to get the relative temperature. Zero on the x-axis is today, and so we're going back to 420,000 years ago. First thing you may notice here is that we have some periodic changes here, both in temperature and greenhouse gases, which seem to match each other. When we have a maximum of carbon dioxide and methane, we also have a maximum in temperature on planet Earth, and it was actually warmer than it was today in some of the interglacial periods in the past. And when we have minimum amounts of greenhouse gases, we actually have minimum temperatures. In fact, the temperature in Antarctica here was about -6, -7 degrees cooler globally than it is today. And this represents the last ice age. The last ice age was around about 20,000 years ago, 18 to 20,000 years ago. And this meant there was a lot of ice on the continents. Greenland, the whole of Canada and parts of the United States were under ice, the whole of Scandinavia, which meant there was less water in the oceans. In fact, the level of the ocean went down by 100 meters. And this resulted actually in a connection between what is today Russia and Alaska. There was a land bridge because the sea level went down because of all the ice on the land. And this was caused by just a few degree cooling in global temperatures. It was colder again in high latitudes, so in Antarctica 7 or 8 degrees cooler. But we see this periodic changes in both in greenhouse gases, in temperature, which we'll talk about in a few minutes. And if we put together on this 420,000 years what's happening today on the right, and notice the scale here at the bottom is only 150 years, whereas every tick before that is 10,000 years. We can see here, if we zoom out, we can see the increase again, the dramatic increases we're seeing in carbon dioxide and methane just in the last 150 years. And now in 2020, the carbon dioxide was 420 ppm, and again the methane is nearly 200% higher, 1,880 ppb. The one thing that the skeptics will then come up and say, the deniers, that, hey, why isn't the temperature gone up anymore? If this is what's happening with greenhouse gases, why is the temperature only gone up by 1 degree? And that's what we see at the bottom here. Why is this such a small increase? Well, this is because, and this is what the scientists will answer, is because the system needs time to react. There's certain inertia to the system, and this is particularly the oceans. If you kick the system or you punch the system, it doesn't react immediately. It takes time, even decades, to reach equilibrium. And so whatever we're doing today to the climate system with greenhouse gases, we'll see that effect in maybe 10, 20 years. And all the warming we're seeing today is likely what we did to the system and the greenhouse gases we put in maybe 10, 20 years ago. And so the oceans take time to mix and to reach equilibrium. We'll speak also during the course. We have a whole week just on the oceans, but the oceans have a major role in impacting the climate, and they have a lag. So if we change something in the atmosphere, it can change in the oceans maybe 10 or 20 years later. And finally, we can go the longest time series, 800,000 years, so nearly 1 million years of data from the ice cores, the bubbles in the ice cores. And here, again, we see the two greenhouse gases, the main ones, carbon dioxide and methane. The carbon dioxide shown in blue. And if we look over nearly 1 million years, the highest concentrations we've seen in the ice cores is around about 300 of these units, 300 parts per million. And again, we can see today, in the 2020, it was 420. So within the last 1 million years, and according to the IPCC, very likely in the last 2 million years, we haven't seen such high concentrations of carbon dioxide. And definitely that's the same with methane. If the highest concentration over the last 1 million years were around about 800 of these units, we're now again at 1,800 and going up. So is what we're seeing unusual? Definitely it is. We haven't seen this likely in 2 million years, these concentrations of greenhouse gases in the atmosphere. And therefore, it's really something to worry about, because from all the laws of physics, with these concentrations in the atmosphere, we're going to see the fever of the Earth going up and up unless we do something about it.